Hello guys, it's your boy Tego. So today I want to build a 5-5 timer which counts from 0 to 9 using the 7 segment display decade counters and using the 7 segment common cathode, which is a 7 segment display, and using a 555 timer oscillators, capacitors and resistors. So today I'm going to show you how to do it using the Proteus 8 Professional. So you say new project here. You want to design a new project, right? Press new project, right? After pressing this new project, we rename it. We say you want to design a 555 timer, which counts from 0 to 5, at the same time counting 0 to 9 using the decade counter, 7 segment display. So press next. Want to do this new project, right? So the first time when you open this Proteus simulator or the schematic capture page here, you press this P here. After pressing this P, you are going to be given some options, whether you want to use the Arduino, you want to use capacitors, Cosmos 4000 series transistors and connectors, etc. So let's pick the devices that we want to use for our project. So for our project, we want the 5-5 timer. That's the most important. So you write 555. This is the 5-5 analog timer oscillator. So we're going to choose it. After choosing it, we are going to pick a 7 segment display decade counter. So you can write it as 4026. That's the code of it. So when we choose this code, you read here, there is 7 segment display decade counter, the Cosmos version. It is 4026. This is the code here. So we are going to pick it, and we are going to pick it. Then we need a capacitor. We need capacitor. So you write cap, want capacitors of the generic non-electronic capacitor, and we want some resistors, right? So we write resistor. So we want resistors, right? So we pick the resistor of the generic resistor symbol, and we pick one resistor. Then we need 7 segment common cathode, which are 7 segment display. So you write 7 sag. We've got the blue in color, we've got the red in color, but you want the red in color. 7 segment. So 7 segments. So you write 7 sag. After you check for displays, right? You check for displays. If you look at this library, there is library for Cosmos, and there is library for 7 STDs and 7 LS and displays that what want the 7 segment common cathode, not the anode. Want the cathode mode. So we have to choose the cathode, red in color. So this is the 7 segment cathode display, right? And we choose this one. Then after that, we press our back so that we can come here at this circuit board here to map our circuit. So first thing we have to put, or we have to place our 5/5 timer oscillator, or 5/5 oscillator. When you say 5/5 oscillator, it counts from 0 to 5 and repeat the same sequence. It oscillates from 0 to 5 and repeat again from 0 to 5. So this is our 5/5 timer oscillator, or we can say 5/5 timer only, or we can say 5/5 oscillator. Let me do this so that you can see. Right, we have to place it here. Right, after placing this 5/5 timer oscillator, we are going to pick this 7-segment display decade counter, and yeah, we want 2 7-segment decade counters. We want the one that counts from 0 to 5 and the one that counts from 0 to 9, and we place them. And we start by connecting this output Q to the clock of the first 7-segment decade counter. So this Q, we connect it at the clock of the first counter here, and we are going to place it sorry. Right, so I want to connect the clock, this clock, at this output Q3, and we connected it, right? And we have to connect the clock, these are the clock at 0.5, which is the CO, right? So let me push this decade counter here. Then I have to connect this other clock at this pin number 5. So let me connect it at pin number 5. I connect it here at pin number 5. After connecting it at pin number 5, I have to connect the MR at the earth, or to the ground, and I need a 12 volts battery. So I have to choose a battery, right? Let me choose a battery. Let me take a battery. And we are going to take our battery here. Let me choose a battery. Not power source, we need a battery, exactly a battery. Let me choose a battery. We want a battery, right? So we want a battery, and we're going to take a DC direct current voltage source battery. That's what I want to use, and I take this one, and we connect the battery through the ground. The ground is connected to the negative part of the battery, so I have to connect it like this. So this is the battery, and I have to connect the ground to this negative. I connected the ground like this. After connecting the ground, I have to connect, this is CV, right? The capacitor times the voltage. So I have to connect the capacitor along this part and connect it through the negative of this battery. So I have to choose this capacitor, right? and I have to place my capacitor here. Let me rotate it, yeah, this way. So after this, I have to connect my capacitor at this point here. Then I have to change the capacitance of this capacitor. I want 10 nanofarads here, so 10 nanofarads, and I connected it to the negative terminal of the battery like this. After connecting it, I have to connect another capacitor at this TR pin. So I have to rotate this. I have to rotate this capacitor again. So let me rotate it. I have to rotate it to the anti-clockwise direction so that it will be in this direction. I have to connect it at this TR, and I have to connect it to the negative of the battery, and I have to connect it to the ground also. So I have to connect it to the ground. So I have to choose, I have to take the ground here, not this one. I want to choose the ground. So I have to take this ground and put it right here and ground this negative of the battery. After grounding this negative part, I have connected this this 7 segment this 5 timer, sorry, or this 5 oscillator. I have to connect it to the ground part of it. And after doing that, I have to connect some resistors. I have to connect some resistors, and I have to connect the power here. So this VCC is connected to the positive part of the battery. So I have to take this VCC and connect it to the positive part of the battery like this. After connecting it, I have to take this R terminal and connect it to this positive part of the battery. After connecting it to the positive part of the battery, I have to put the power source here. Then I connect it to the power source. After doing this, I have to connect a 10 kilo ohm resistor. So let me choose a 10 kilo ohm resistor, right? So I go here at resistors. I have to put a 10 kilo ohm resistor. I need 2 of them here. I need the 2 of them. So this is the first one, the 10 kilo ohm resistor, and I have to place another one here, and I have to rotate it. This is another 10 kilo ohm resistor. So I have placed the 2 resistors, and I have to connect them. This, I have to connect it to the positive terminal of the battery, and I have to connect the other one at this resistor, and I have to find a junction here that connects to this DC terminal. After connecting it like this, I have to connect this other to this 6 terminal like this, right? I have to connect it like this. After connecting it like this, I have to bridge 6 and these 2. They must be connected. They must share. So I have to remove these labels to this side. After that, I have to connect it like this. I have to bridge these two. After connecting them like this, I have to take the 3 going to the clock. As you can see, I'm done. These 3 will give the signal to this 7 segment decade counter, right? After doing that, I have to connect the INH and the MR, bridging them like this. After bridging them, I have to ground them to the ground straight. So I need the ground here so that I can ground these two. I have to place it to the ground like this. And I need a power source, so I have to put a power source right here to connect it at this point 3 to power this 7 segment decade count. After doing that, I have to connect this 5 to this to this clock. After doing that, I have to bridge again, like what I did at the other decade counter. I bridge it with this 15, and I have to put the ground to ground everything here. I have to ground everything here. After grounding everything here, I have to place the power at position 3. So I need the power here to power this oscillator. Then after this, I have to place the displays that will count the numbers. So I need the cathode displays. I have to place one here and connect from 10 to 7 here, and I need other one here, right? First thing, I have to ground everything here. First thing, I have to ground everything. I have to ground. I have to ground. Let me check for the ground. I have to ground this terminal here, and I have to ground the other one, this one, like this. After doing that, I connect this terminal 10 at this point, and I connect this terminal 12 at this point. I connect 13 at this point, and I connect this 9 at this point, and I connect this 11 at this point, and I connect this at this point. This one, I connect it at this point. I do the same here. I connect this one at this one. Connect this one and this one. Connect this one and this one. Connect this one. I connect this and this. Right. When the circuit is like this, then it is now a complete circuit. I can now turn it on, but I have to put a 10 kilo ohm resistor, and here I must place a 100 kilo ohm resistor for it to work properly. I have to place a 100 like this, and here I want a 1 microfarad at this capacitor 2. I want 1 micro, which is 1 U. I need 1 U like this, and I have to make sure the battery is 12 volts, and I have to run the simulation of this circuit, and the circuit works. So when I say a 5-5 timer oscillator or a 5-5 oscillator, that count from 0 to 9, or a 55 timer 0 to 9 decade counter. This is the decade counter, and this is a 55 timer. So as you can see, that this one counts from 0 to 9, and this one counts from 0 this one counts from 0 to 9 again. There must be a difference. This one must count from 0 to this one must count from 0 to 5, and this one must count from 0 to 9. There must be a difference. This one must be a 555, which means it counts from 0 to 5, and this one must count from 0 to 9. So you adjust this resistance and adjust this capacitance so that it will work accordingly. Is what we want. So thank you guys. This is how you design this 55 timer oscillator circuit. I hope you learned something. Please subscribe, like, and comment for more videos. I'm going to do some other videos for Arduino simulations and other simulations. Thank you guys. Have a good day.